Welcome to Leaders in Lending. I'm your host, Jeff Keltner. This week's episode features my conversation with Peter Voss from Aigo. And Peter's actually the guy who, back in the day, in the early 2000s, coined the term artificial general intelligence. So to be a little outside of our normal vein, we're going to go deep on AI in this conversation. And it was really fascinating for me because we talked about the recent explosion of interest in generative AI, what it does well, what it gets wrong, like hallucinations, and why Peter is both optimistic about our ability to create artificial general intelligence, not just specific intelligence, but a very generalizable, flexible intelligence, but also that the general technologies around statistical AI that underpin most current approaches are really not the right way. And so he talks about his approach to what he calls cognitive AI, what they're building on that front, what he calls his chatbot with the brain, and what the future looks like for generalized intelligence, generalized artificial intelligence. So I think it's a really fascinating conversation for anyone who's curious about what's going on in AI, what's next, and maybe talk about the edges of where some of these things are not working as well and why. So please enjoy this conversation with Peter Voss. Peter, welcome to the podcast, and thanks for making the time to join us.
Yes, well, thank you.
I'm looking forward to this conversation today. It's been a little off the beaten track compared to many of my conversations with bankers. I don't think we'll go down any deep banking rabbit holes. Mm-hmm. But you've got a little bit more of a background in AI. So give us a little bit of your history just so people can have a little context of where you're coming from and what you've been doing for the last number of years.
Yes, certainly. So I actually started out as an electronics engineer and started my own company. And then I fell in love with software and my company turned into a software company. I developed an ERP, a comprehensive ERP system for small to medium-sized businesses. And that company did quite well. We went from the garage to 400 people and did an IPO. So that was very exciting. Love to do that again. And it's when I exited that company, I, said, well, what do I want to tackle next? And what occurred to me is that software really isn't inherently very smart. If the programmer didn't think of something, then it'll just crash or give you an error message or, do something stupid. So I really wanted to figure out how can we build software that actually has common sense, that can learn, that can reason. So that's a journey I've been on for the last, 20 plus years. And I took off 5 years to study intelligence, all different aspects of intelligence to be able to build an intelligent system. But I thought I really needed to understand it. And so I studied how children learn, how our intelligence differs from animals, what IQ tests measure, all the work that had been done in the field of AI. And that study culminated in me coming up with a theory of how to actually build a thinking machine. And then 2001, I started in my first AI company. And for several years, we were just in R&D mode, sort of turning my ideas into actual code, prototypes, and eventually a platform that we then commercialized and automated calls and call center automation, and doing that a lot more intelligently than what had been done before, because we have a cognitive engine that actually deeply understands what you're saying, uses context, uses history of what you said earlier in the conversation. So it has short-term memory, long-term memory. And that's really the journey I've been on. So my current company also commercializes conversational AI. But we also are continuing to increase the IQ of our system. We really want to get to full human level intelligence.
It's fascinating to me, the discussion about human intelligence and how close or not. I mean, there seems to be this very wide range of opinions in how close some of the, at least the consumer-facing cutting-edge technologies, things like Claude or Bard or ChatGPT is probably the most popular, and that transformer architecture that seems to have kind of revolutionized the quality of conversation we're having. And I hear everything from people who think we're like one turn of the crank on that architecture from having like a superhuman brain, and people who go, hey, we're just not even on the right path. You're kind of doing this thing. And I'm kind of curious where you stand on that and what you think true human-like intelligence requires. I mean, it's not just like being able to hold a conversation. I think the Turing test is maybe out of date in terms of how we think about what a truly intelligent machine needs to look like. So what's your perspective on that? How far or close are those kinds of technologies? And what do you think, if anything, they're missing in terms of how their approach generates or tries to mimic intelligence in humans?
Yes, it's a very interesting and a very important question at this point in time, because ChatGPT became available. I think it really was a major shock to many people, and including pretty much all AI researchers. Virtually nobody expected the system to be as good as it, to be able to hold the kind of conversation that it can, and the amount of knowledge that it has.
That's one of the most fascinating things to me is the people who built it really I kind of describe it to people as like a really fancy autocomplete. And then how it got to things like reasoning and understand, like they really don't understand how that emerged. They really build a reasoning system. They built like an autocomplete and somehow it has some basic deductive, it's like they're really surprised by what it can do.
Yes, absolutely. And, I think there are certainly ways of understanding it, but there are, as impressive as it is and as useful as it is, there are inherent fundamental limitations to that. And it's difficult to look past the sort of impressiveness of it. It just seems so intelligent. It's really good at faking intelligence. And of course, it can do really, really amazing things. But the problem is it's really not reliable. It's not aware of what it's saying at all. So there is no metacognition. And so there are a couple of components that are really missing to truly make it human-like and human-level intelligence. So, and in fact, the name GPT gives you a clue already. G stands for generative, and which, another way of saying it makes up stuff. And it literally does. I mean, you can prompt it and ask, I can ask it, tell me about the white paper I posted on kidney revival or something, and, it'll come up with something, complete.
Those lawyers recently who asked it a question, and they came up with like 3 precedents and they submitted them in a brief, and the judge went, those are real cases. You can't just, so that was, so they got to find, I think, $2,000 for professional misconduct. It's
Right. That's exactly right. So, I mean, that's the generative part, and that's inherent in generative. It's trained on trillions of pieces of information, good, bad, and ugly. And, what it comes up with is really just that it's sort of coherent in its statistical model, but it doesn't need to bear any kind of relationship to reality. And so that's inherent. It's just an inherent limitation of the system, the way it's built. Now, the second part is GP is the pre-trained, and it's really a read-only model. They build the model. It costs, $100 million or whatever, some enormous
outrageously large
amount. Yeah, and it takes, days or weeks to train the model. But then it's essentially after that, it's largely read-only. Now, it cannot learn interactively. Now, there are tweaks that people, that the system allows, that it has some kind of a short-term buffer that it takes into account. That's basically the prompts you feed in. But that information doesn't update the model. So whatever you teach it there is does not change the model, which is very different from the way humans operate. I mean, we can hear one word or 2 words, and it can completely change the way we perceive things. And like Trump won. For better or for worse. I mean, it changes everything. If you didn't expect it. So it updates our model basically. Certain things, just 1 or 2 words can really update our model significantly. And I think that's what intelligence requires. And then what I already mentioned is the lack of metacognition. It doesn't know what it's saying. It can't think about its own thinking. So these are requirements, I think, of real intelligence. I mean, imagine hiring an assistant, a human assistant for you, and they come and I can do Excel and I can, do PowerPoint, and I can, do whatever, look up things on the internet for you. And then you tell them, well, we introduced this new product, we shut down one of our branches, we have this new relationship, and so on. And next day your assistant comes in and they don't remember any of that,
Yeah, my son had an article to respond to today. He's a middle school 6th grader, and he had to write a summary. And, we were talking about this exact point because I said, imagine what your history teacher would do if she gave you a lesson And then you said, hold on, give me a week and $100 million and I'll come back and be able to pass the test. But between now and then, I won't have any memory of what you said. You wouldn't pass sixth grade very well, let alone a job interview or do well in the workforce. So it's kind of unbelievable when you think about how young a person would have a better level of intelligence from that real-time learning perspective. It's really quite remarkable.
Right. And it's absolutely crucial for intelligence in the real world. You need to be able to learn things on the fly and think through what the implications are of the new knowledge that you have. And this technology simply cannot do it. Transformer technology cannot do it. So we need a different approach. And the approach that I believe we need is something called cognitive AI as opposed to statistical or generative. And cognitive AI really starts with the question of what does intelligence require, and to build the system around that. Where statistical AI started with, hey, we've got a lot of data, we've got a lot of computing power, the big companies like Google and Facebook. So what can we do with a lot of data and a lot of computing power? That's the hammer we've got. So what nails can we find? It's not starting with what does intelligence require, and that's really I think the approach that's needed, and that's the approach that we've taken.
Do you see any kind of recognition? I mean, it feels like there's so much money and investment pouring into the generative AI space now, whether it's, everybody trying to catch up with ChatGPT in terms of Anthropic, or Google investing in Claude and Bard, or whether it's VCs investing in startups. But they're all using the same kind of statistical AI approach, right? They're iterating on the transformer or the diffusion models in the space of image generation. Do you see enough investment going into this kind of like new approaches? Because it feels like we're all iterating on the same thing versus trying to build the new thing. There's so much resource going there. I wonder what your thoughts are on that versus seeing more investment into different approaches that more closely mirror what we think is going on in human intelligence and might be required for a more generalized intelligence capability.
Right. Well, obviously it has a lot of momentum, and really I think since really the .com boom, people really only think in terms of momentum investing. It's basically, where are things happening? Hey, let me pile in, let me put more, and that has a flywheel kind of effect, that the more people jump on, the more money comes in, you can't even do a PhD on computer science if it doesn't involve machine learning, deep learning, statistical systems these days. You're probably not going to get funded on a VC if you're not using that. So it has that effect. And I think what's happening now is there is a realization of, hang on, these are real limitations that we have. We cannot trust these systems. They cannot learn. They don't have metacognition, and they're incredibly expensive to run and to train. So people are starting to realize it, but the momentum has to kind of work its way out. And I think a lot of VCs have to lose a lot of money, which I think is going to happen soon. As these startups that try to capitalize on it just find, what are actually applications that are creating value? Now, there are a lot of applications that create value, such as a programming aid, and to help you brainstorm stuff, or to generate images or logos, or things where there's a human in the loop using it as a tool. But there's a limited amount of value that creates. It doesn't really replace human labor on a large scale, and that's really where the real value would be created if it could do that. So I think we'll see the tide turning. The problem is almost all of the experts in the field, the only thing they know is statistical approaches. So you have a whole ecosystem where the AI experts, in fact, if you talk to somebody now who graduated in the last 10 years, they actually think that AI is statistical. That's it. There is no other approach to AI. So you basically have all of the experts in the field that their background is mathematics, statistics, and logic. And those are kind of the only way they can think about the problem. So it's going to be a pretty difficult, to have that whole ecosystem really change to say, no, these approaches are not going to get us to true human level AI. So I don't know how long that will take, but we're certainly seeing an increasing realization of what the inherent limitations are, and you can't just brute force your way to human level intelligence.
Yeah, it's interesting when you talk about the evolution of companies and how they invest in this or not. And it reminds me a little bit of like the moment when Google was founded, because it feels so inevitable looking back what Google became and what it is. But like search was considered by many a solved problem. And they're like, there's not room for another search engine. There's Lycos, there's Alta Vista. Like, what are you guys doing starting a search engine right now? It doesn't make any sense. And they were clearly off the mark. And I think that feels like the same inevitability that Google looks like in retrospect behind the guys, OpenAI and ChatGPT, for instance. But it is often true that that's the moment when the true innovation comes out and new things are founded that end up looking inevitable in retrospect, but maybe foolhardy at the time. And maybe it's one of those moments for a totally different approach, despite the large influence that some of these companies have right now.
No, you make an excellent point there. And I mean, yes, how could a little startup Google possibly compete against the existing, established search engines? You take the same with Amazon. How could some, little Mickey Mouse online bookstore possibly take on Walmart, And we see that again and again. It's, at a certain point, the establishment is fixed on a particular approach, and they really can't break out of it.
So I want to ask you a little bit about what you guys do. You described it to me once at your company as a chat bot with a brain, one of the products you have. So talk to me about how that plays out in a company and what you mean when you say with a brain. Like, that's an interesting phrase, I think. I'd love to understand where you're kind of coming at from with that.
Right. Well, all the other chatbots out there, as far as I know, do not have a brain. And what we mean by brain is basically a cognitive engine that has deep understanding, uses context, has short-term memory. It remembers what was said earlier in the conversation, has long-term memory. It remembers previous conversations with each individual. So it really has a comprehensive cognitive engine or brain that manages the whole conversation. And other chatbots really use an approach that's been around for 30 years or so. So on the one hand, you have an intent classifier where, whatever the utterance is, blah, 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 weather, okay, it triggers a weather app. Or you say, I hate Uber, don't ever give me Uber again. Well, it'll probably still trigger the Uber app because it latches onto that. So it's a fixed list of options that can get triggered. And once they get triggered, there's basically a little flowcharty type program that somebody writes. Where do you want to go? How many people are going? And do you want Uber X? So there, and then obviously people have different levels of sophistication where they may hard code certain terms to be remembered. So there may be some very limited specific short-term memory or long-term memory. They look up something in the database, but it's not an inherent part of the architecture that there is deep understanding, context is being used. The system reasons about what it hears. And so with a brain, you can have a much more sophisticated conversation. So as an example, one of our customers is 1-800-Flowers, a group of companies, which includes Harry and David, Popcorn Factory, and so on. So they use our system very, very successfully to provide a concierge type service to their 20 million customers. And so our system remembers who you buy gifts for what occasion, what kind of gifts they like. It's able to do that because of the deep understanding and the memory. So, this is where the brain really allows us to handle very complex conversations. And the same approach, can be applied to, banking or medical applications or whatever. I mean, we've all experienced how limited IVRs, voice interactions and chatbots are. Bank of America, Erica, I think they have like what 3% repeat usage or something. Very, very low number in spite of hundreds of millions of dollars being spent on that. They don't have a brain.
That's fascinating. I'm curious, where do you think you guys are at in taking the architecture from what it's being used for today to more generalized tasks? I mean, you talk about replacing human labor on a large scale. Where are your systems at in the ability to move from a call center or chatbot type interaction to, more generalized cognitive capabilities and types of labor?
Yeah, so over the last few years, our concentration has been to really build out the infrastructure, the robustness, and scalability and ease of implementation and all of that. So our focus has been very much on commercial aspect of our technology, but we now have a very solid system. And our focus is actually shifting back again to cranking up the IQ of our system. There's still quite a ways to go to scale up the amount of knowledge that the system has, the degree of complexity of what it can handle, how it can handle, for example, theory of mind. What is the other person thinking? What does the other person know? So we need to scale up our brain in various areas to handle these more complex situations. Also, at the moment, there's still a fair amount of work involved in actually teaching the system the specifics of each company that use our system. And as our system becomes smarter, it will be able to self-configure to a much larger degree, where it will be able to ask the question, do you want me to handle it this way or that way, or let me read your training manuals. At the moment, there's still a human in the loop in for many of these training exercises. So as we crank up the IQ, the implementations will become much easier, and it will be able to handle even more complex situations and conversations. So we just recently sort of rebooted our development focus. We currently have about 10 people working on that full time, but we are actually in the process to raise money to increase that to 100. We want 100 people on that project. We know what we need to do to crank up the IQ to get to human level intelligence, but we're currently looking for funding, and so we're looking for the kind of visionary investors that can look past the bandwagon that everybody's jumping on and say, well, what does intelligence really require, and who has potentially a solution for that?
I'll be honest, Peter. I think one of the most surprising things for me from the pandemic was how well the last mile of the internet infrastructure held up. But it feels like in the last 6 to 9 months, the weight of of 2 years of work from home has come down on my internet. So I have days when I'm just blazing fast and days when
maybe Starlink.
Yeah, they got their. Maybe I've got to go to Starlink. You would think in Los Angeles you wouldn't have to, but I get ads from Verizon and T-Mobile. They drop mailers off at my house about their amazing services, and I call them. They go, "We don't support your area yet." And I go, "Well, you should call your direct mail team and tell them that before they drop another flyer off at my house, telling me about how awesome your wireless internet or your fiber optics to my house will be, because I can't get any of them. I'm stuck with like Spectrum, and it's."
Yeah, no, fiber is fantastic. That's what we have here.
Yeah, we have that in the office, but Pasadena, old school town, Rose Bowl, Rose Parade, does not have fiber optics. So we're still dealing with what we got. Anyway, I apologize for the lack of video. I turned the video off just to hopefully keep the data moving.
I assume you can edit the thing sufficiently
and the reason we use this particular software is it records locally the audio and video from each of us, and then syncs it later, so it doesn't impact the recording quality. Other than my making faces at the computer when your audio drops out, the producers are going to have to deal with that. It's not our problem. Somebody's going to have to deal with that. I'm fascinated by this idea that the smarter version of your iteration of your program will start to kind of be able to train itself. I mean, what are the things you think what are the real markers of as the system gets more and more intelligent, like the self-configuration, asking for the data it might need to be able to respond more accurately is a really interesting one, kind of like self-directed learning, which is very different, I think, in the way we might use those terms today. But what are the markers you see of like how this evolves and how you can tell that it's getting smarter and smarter? Like what are the, there's not like a ninth grade test, a high school test you want to pass the way GPT, I think, passes the bar exam or whatever. What are the markers for you as you get farther down this line of real cognition and you're ramping up the IQ of the system? What does that look like?
Yeah. So it's very different for us. This is not a black box. So it's not that we kind of keep throwing more data and computing power at it and then, wow, what can it do now? Wow, that's cool. Okay, can we tweak it a bit here and there to make sure it doesn't swear at us or say naughty things, or whatever? That's not at all the approach. I mean, with the cognitive architecture that we have, it's completely scrutable. So we can see what it's doing and why it's doing what it's doing. And so we have a curriculum that we're going through to enable the system to handle more and more complex tasks, to handle more and more complex reasoning. So, there are little surprises along the way. We say, wow, this worked a lot better than we thought it might, or this is a lot harder than we thought. And it takes more time, but we really have a particular development path that we've mapped out to get from where we are to get to full human level intelligence, and it's just an incremental path, and it requires a fair amount of effort, not billions or trillions of dollars, but certainly tens of millions. For us to we need 100, 200 people working on this to really get to human level commercial product, but we have a very specific roadmap to achieve that.
What kinds of things are on your curriculum? I'm curious. I always ask my kids' teachers for their curriculum for the year. What are the kinds of things just conceptually that are on the curriculum for your system?
Yeah. So with a new project that we have now, is one of the big changes is our commercial product. The language ability was really put in by humans. We fed it the different language rules and so on. So there was a lot of curation being done, and we've always known, and we've known for the last 20 years that we've been developing the technology and commercializing it. We've always known that ultimately the system has to be able to learn language by itself, essentially, with a teacher. So our current focus is on, finally replacing these human-coded rules with a knowledge that the system acquires. And so that's the curriculum we right now are doing, is to teach it the basic language skills interactively. And that curriculum certainly has some overlap to the way children learn. There are layers of what is the most fundamental knowledge that you need to have, about things. There are objects, there are activities, there are attributes, there are entities, there are general categories. And those things have to be kind of very deeply embedded. So that's our focus right now, the curriculum. Now, as we do that, we will then go back to the kinds of things we've been doing. Is how do you take an order, or how do you interact with APIs to achieve different things? So that'll be the curriculum that we execute as we go along.
That's a fascinating journey. I can't wait to see what comes out of it, because it seems like a very interesting and different approach, and it'll be really interesting to see how. Hopefully, your system doesn't have the same kind of teenage angst and difficulty that humans do. But the interactive learning seems like a very interesting.
No, it will not. We're not going to inject it with hormones, or so it's not going to have to go through puberty or any of that. So that's thankfully not something we have to deal with in our AI. But I am so excited about working on this project, and I have been for as long as I have been working on it, because of the tremendous potential that it has. And, I mean, I could name just like 3 categories. The first one is, imagine having a true PhD level researchers, AI researchers. You get one that gets trained to be a cancer researcher, for example, with all the background knowledge. Then you can make 1 million copies of that. You now have 1 million PhD level cancer researchers chipping away at the problem. I mean, we're going to make much, much more progress. You take that for other diseases. You take it for energy, for, battery efficiency, for pollution, climate change. All of, having these PhD level AIs chipping away at these many problems that are facing humanity. That's kind of the one area. The second area is obviously dramatically reducing the cost of goods and services by having a lot more things automated. I mean, human labor is the bottleneck for affordability in many things. And the third one that is actually, in my mind, even the most exciting one, is what we call a personal assistant. And it should really be called a personal assistant because of 3 different aspects of personal. So the first personal is that you own it. It serves your agenda, not some mega corporation's agenda. The second personal is that it's hyper-personalized to you. So it learns your preferences, your history, your goals and your likes, your dislikes, and so on. And the third personal is the one of privacy, that you decide what you want to share with whom. So, certain things you share with your spouse, other things you share with your coworkers, and yet other things you might share with Amazon. So, all of these things are going to be possible with true human level AI. And I think it will be tremendous to improve the quality of life, and basically help us flourish.
I love it. And your second point is interesting because I often describe current generative AI technologies to some people in other AI technologies is, what would you do if you had unlimited free interns? Like not super talented people, but people who could image process, write basic copy. Like how would you leverage that in your business? And you're talking about a world in which you have maybe not unlimited, maybe not free, but a plethora of highly trained experts in different areas. It's a fascinating thing to think about what you could do with that capability in the world.
Yeah. And the important thing is the ability to learn in real time, that they can learn these tasks by themselves the way a human can. It's not then having to go through a training process, and whatever you train that's limited to what it can do, what the training is. Now, this is truly dynamic, ongoing learning, reasoning about it at a high level, and that it's a completely different approach from the statistical generative AI, and you're not going to have these surprises of where it says something with great confidence that is just completely, utterly wrong.
Well, that may be a good mirror of some humans' intelligence. I've met plenty of people who also say things with a high degree of confidence that are completely wrong, but maybe not the one we want to mirror in our AI systems. Right. Well, Peter, this has been a fascinating conversation. I really appreciate you making the time today. It's given me a lot to think about, and I'm sure the audience as well. I do have a couple of traditional closing questions I'd love to ask you before we finish up here. And the first of them is, what's the best piece of career advice you've ever gotten?
Well, for me personally, I can kick myself that I only started my first business when I was 25. I should have started when I was 16. Now, this is not going to be, true for everyone, but for me, it's until you actually, if you aspire to run a company or to be part of the core team, you really just need to get the experience. It's just completely different working for a boss as an employee than having the responsibility of running a company. So if that's something you want to do, the sooner you can start. I mean, whether it's part-time, whether you do it even for free, just to gain the experience. But to me, that, if I have to say one regret, that I only started at 25.
Well, that may be a good mirror of some humans' intelligence. I've met plenty of people who also say things with a high degree of confidence that are completely wrong, but maybe not the one we want to mirror in our AI systems. Interesting. Reminds me of advice about parenting that you can never really understand it until you do it. And if you're waiting for a better
Yes.
time, like there isn't really a better time. You just got to go out there unprepared as you are and learn on the job because it's really the only way to learn.
Yes. Yes.
And my last question, which maybe we've been talking about, this may be an easier one for you because we've kind of been going on this all days, but as always, I ask everybody, what's one bold prediction for the future?
That we are going to have AGI, and I believe it will be fantastic for humanity. It will really help us manage the many difficult challenges that are facing us.
Well, I love that. That's a great place to leave it, Peter, because it's certainly, I think, possible and would be an amazing opportunity and exciting development as we get there. So I hope you're right on this one, and we'll be watching carefully because it's a very exciting time and lots of stuff going on. So thank you so much for making the time to join us on the podcast today.
Yes, thanks for having me. It was fun.